Hi and welcome everybody. Welcome back to part three of physical layer authentication. In this part, we will discuss the types of physical authentication, and we will start with with the passive approach, which is related to device-based and channel-based approach. And later on in the coming lectures in the next coming week, we will discuss the active approach, hopefully including the physical watermarking. So, classification of physical layer authentication techniques, as we agreed, passive and active. Passive, it means from the channel and from the RF front end. And active means related to physical watermarking. You are adding something additional, embedding something with the transmitted signal. And for the passive physical layer security, it's based on the physical layer features of the received signal. Example, the radio frequency characteristics due to hardware imperfections or channel characteristics. Now, when we discuss channel characteristics, there are so many characteristics and features that we can extract from the channel. And you use these features and characteristics to distinguish distinguish between the channels and classify them. This channel is related to this device, that channel is related to that device, and so on. And the same thing can happen and apply to RF front-end characteristics. The active physical layer authentication is based on a tag assisted by a secret key. You add something to the signal, basically in general, and embeds it into a source message. The receiver authenticates the transmitter by using the embedded tag in the received signal. Now, there is a famous example that we will explain here when we reach to active physical layer security, but we also will return back to one of the techniques that we explained for providing confidentiality, and we will study it from the authentication perspective, and we will see how that technique can also provide authentication alongside confidentiality, and see why and how. So this is we are starting with passive physical layer security and passive physical layer security authentication, dividing it into hardware-based and channel-based. And here we will explain the steps one by one of how physical layer authentication based on channel characteristics can be executed. So we have first two stages, the training stage over here, and we have the message transmission stage. So in the training stage, we have four steps that Alice and Bob has to go through, and they have to handshake some messages in order to extract some features. And in the second step, it's the process in which they really authenticate each other or reject each other. So let's go to step one. In this step, Alice sends a request to Bob. Alice wants to communicate with Bob. Alice sends a request to Bob for message transmission over a wireless channel. Bob received the request at time T1. In step 3, Bob first checks whether the request is legitimate or not through upper layer authentication mechanism. Then if it's legitimate, Bob extracts some physical layer features from the received signal to construct a whitelist. Otherwise, Bob ignores the request. Now, as you can see in this detailed approach, physical layer security is implemented as a complementary solution to the upper layer authentication approaches, which means that here we are not saying up until now, we are not saying that we can get rid of the upper layer authentication, but we can say that physical layer authentication can improve and can strengthen the overall authentication process. Okay, but later on, after this, we will move to a new stage where we can show you how physical layer authentication can get executed independent of the upper layer authentication. But here we step by step go and we study all the techniques that are available in the literature and what the developers and researchers are doing in this domain. For this, the authentication, Bob first checks whether the request is legitimate or not through an upper layer authentication mechanism. Then, if it's legitimate, Bob extract some features. So, okay, the signal I received is coming from a receiver, is coming from a transmitter. I already know him. Why? Because the key that he's using to transmit his signal is already available in my database, and this key is coming from the upper layer. So then I start, since I have some initial trust about this user, I start recording his physical layer, recording, extracting, and storing his physical layer features or characteristics from the received signal. And the reason for that is to construct, which means to build a whitelist, a database of the features related to that user. Then step 4, Bob sends an ACK to Alice for preparing a message transmission. In the message transmission stage, it compares with the existing database. Alice sends a legitimate message to Bob over the same wireless channel as that in the training stage. Bob receives the signal transmitted from unknown transmitter at time t2. Bob extracts physical layer features from the current received signal and compares them with corresponding ones of the whitelist. Based on the comparison result, Bob can determine whether these features exist in the whitelist. If yes, Bob accepts the received signal, otherwise Bob rejects it. So the upper layer authentication here in the training phase was used once to be able to make sure that this is a legitimate transmitter and I should allow it to get into my network. And then I extract some features about his channel. And after that, I start using his feature to authenticate it instead of using the key. Any questions? Clear? These are the steps of passive physical layer authentication in general. 2 stages, and each stage is 3 to 4 steps. And here in visualization, you have the training phase where they make database at the verifier, the authenticator, and then during the message transmission, the new signals are compared with what's stored in the database. If it matches, it's okay. If it doesn't match, I reject. And these are examples of what you can use and the features you can extract. So the channel or RF front-end features, training phase, making database at the verifier. So you have the channel here, you have Alice and Bob, signal pre-processing, feature extraction, you store these things in a database, and then you start using them to verify or authenticate any new signal. Now we will talk about hardware-based passive physical layer authentication using hardware-based approach. In this case, device-based features reflect the hardware imperfection of the transmitting device, and these features include carrier frequency offset, IQ imbalance, and the clock skew. The carrier frequency offset. So the carrier frequency offset is related to the oscillator at the transmitter and receiver. And the IQ imbalance and the clock skew. So these are hardware features, hardware specifications that are usually unique to a certain device. And if we measure them successfully and store them in a database, we can start using them to authenticate devices. So among these features, we have local oscillators from which you can extract phase noise and carrier frequency offset. We have from power amplifiers, we can extract power amplifier imperfections to the signal. From the device clock, you can extract the clock offset and the clock skew. From the RF modulation, you can extract I and the Q imbalance feature. And all these can be used for feature extraction or selection. And you can determine the number of features you can select, the type of features, and the weighted feature, the importance of the feature. For example, the feature that you think is more reliable, you can give it a higher weight. The feature that you might think it's a little bit not that reliable, you can give it a lower weight. And you can select multiple features altogether. Application scenario, the device-based passive physical layer authentication schemes can be applied to Wi-Fi systems, cellular system, ADOC system, ZigBee system, OFDM system, WiMAX, and network cards, as well as Bluetooth systems. So this is where you can apply such kind of techniques. So this is related to hardware-based authentication, and this is channel-based authentication. In the channel-based authentication, you authenticate based on the channel state information between the communicating nodes. And the channel should be reciprocal, which means the uplink is the same as the downlink. And because both the transmitter and receiver are using a TDD system, time division duplex, where the uplink and downlink both use the same frequency. And we need to pay attention to the fact that sometimes, due to having different interference at the uplink from that in the downlink, there we might have a mismatch between what we estimate in the uplink and downlink. So the channel-based, we have uh, two subcategories related to channel-based. The first one is using the received signal strength. The strength of your received signal can be used to authenticate, or the channel state information, which includes the channel impulse response and the channel frequency response. And we have two types of channel information. We have the statistical channel information, which is determined by path loss and shadowing effect. We know path loss is dependent on the distance between the transmitter and receiver and the frequency being used. And shadowing is dependent on the number of objects that obstruct or blocks your signal during its transmission from the transmitter to the receiver. And we have another type of channel information called instantaneous. So instantaneous is different from the statistical because it's determined usually by small scale fading effect alongside path loss and shadowing. Small scale fading is related to the multipath reflections in the environment caused by different objects in the medium you are transmitting over. So imagine you are transmitting your signal and you have a receiver that's 100 meters away from you. The signal that you transmit while it's going to the receiver, it hits many different objects, and each object imprints its own unique characteristics on it. For example, when the signal hits a wall, is different from hitting an iron door or a wood door or a window or an aluminium kind of a surface. So imagine your signal, how many objects it will interact with, and all these objects put their own unique imprints on the signal, and all together they can be captured by the receiver. The distance affect, the velocity affect, the objects, the type of objects, the material of the object, And all these things can be embedded inside the channel, inside the signal received at the receiver, which can be used to extract the channel from, and this can be treated as a unique identifying feature for the transmitter. So if we were to compare between statistical channel information and instantaneous channel information features, you can say that the statistical has low complexity and high robustness. Instantaneous is lower robustness but higher security. The disadvantage for statistical features is low security because you don't have too many features to extract it from because it's just dependent on the distance and the frequency, the path loss. But for instantaneous channel information, you have lots of features that you can extract and build upon. The trade-off, the trade-off exists between among security, robustness, and complexity for both statistical features and instantaneous features. Here we continue with the channel-based approach. We have two different types of channels. We have the time invariant channel and the time variant channel. As the name implies, time invariant, it means the channel is not changing with time much, it's almost stable. And in this case, we don't need channel tracking to track the channel and see if it changes or not. The channel is highly correlated in time so that the estimation results can be almost the same between adjacent time slots. Time invariant Time variant is the opposite of time invariant channel, where you need tracking. And in this figure, we get uh, a deeper look at time variant channel, where we have two axes here, the x-axis and y-axis. The x-axis represents the tau delay in time, and the y-axis represents the changes in the channel, how fast the channel changes. So the x-axis, we study how spread out the impulse response are related to the physical layout of the transmitter and receiver and reflectors at a single time. So the values of these samples and the x-axis are determined by the location of the transmitter and receivers and the reflectors, the objects, the number of objects between them, and their types and their material. And this in the y-axis, we study how fast the channel changes over time related to moving speed of the transmitter and receiver and the reflectors. This is related to not to the type or location of the transmitter and receiver and reflectors, but here to their speed and movement, because the movement of these objects can cause and will cause changes of the channel in time domain, and this requires you to track it to be able to update your channel frequently. And in the literature, we have many channel tracking algorithms that are used to track the channel behavior and the changes in the channel. We also have rich scattering channel and sparse channels. So rich scattering environment, it means you have so many reflections because you have so many objects around the signal that you are transmitting. A sparse channel means the delay spread between the tabs, the multiple paths, are usually sometimes sparse. There are periods where you don't receive any tab, and all of a sudden you receive multiple tabs. So at a certain times you don't have any signal received at the receiver, but later on you have bunch of signals being received. Now, the channel-based passive physical layer authentication schemes can be applied to MIMO systems, dual hop wireless network, OFDM systems, CDM relay network, and so on. Now, this is all what we have to say about passive physical layer security, which has two types, the channel-based and the hardware-based, and the features we can extract from them. Of course, this requires deep knowledge in the wireless channel, which is a topic by itself alone. You can give a course about it, and deep knowledge about the hardware impairments and their characteristics and their uniqueness. Uh, Once you have this deep knowledge in these two domains, hardware and channel, then you can utilize this knowledge in order to extract some features that can be used for authentication in different application scenarios, of course. And next lecture, we will continue with the active physical layer authentication using watermarking and discuss these slides and the math behind them, and give you some other examples of some other techniques that can provide uh, active physical layer authentication, and then give you insights and challenges.